Okay, welcome back to Mr. Hassan's Maths channel. I'm now answering question number 8 from the May-June 2019 IGCSE Cambridge Paper 4 Variant 1 exam. This question is about percentages mostly, and it says the price of part A, the price of a book increases from $2.50 to $2.65. Calculate the percentage increase. Now the percentage increase is equal to the difference between the original price and the new price. Okay, and this thing has gone from 2.50, sorry. So it's gone from 2.50 and it's gone up to 2.65. So this is the original price and this is the new price. So the percentage increase is basically the difference between the two prices divided by the original price times 100%. So in this case, the difference is going to be 2.65 minus 2.50 divided by the original price, where it started from, which is 2.5, and you multiply that by 100, okay, and leave it in terms of percentages. Okay, so you're going to have 2.65 minus 2.50 divided by 2.5. Okay, and then that is multiplied by 100. The percent here is like the unit, you could say. You don't put 100% here, you put times 100, and that gives you the percentage increase, which is 6%. So it's a 6% increase. That's part A. There's also another way of doing this. An alternative way of doing this is you can say before and after. So you can say before its price was 2.50, you can say that's the original price, which is 100%, and after it became 2.65, and you want to find what percentage that is. Well, we actually want to find the increase. All right, so you'll see what you have to do here. So if you want to find what x is, in fact, it's better actually in this type of question to write it the other way around to make life easier for cross multiplying. So I'll write down the knowns underneath. So it's 2.5 to 2.65. And this is 100%. Its starting price, its original price is 100%, and this is the new price, which is increased by a certain percentage, which we have to find. So we can cross multiply. We can say x equals 2.65 times 100 divided by 2.5, and you see it's going to be let's see, 2.65 times 100. Let me put it in one thing. 2.65 times 100 divided by 2.50, which is 2.5. Now that gives you 106. That's 106%. So the percentage increase is going to be, this is 106, that's 100, so it's increased by 6%. It's 106% minus 6%, which minus 100%, sorry, which is 6%. Okay, so it's gone from 100% to 106%. That's an increase of 6%. All right, so that's an alternative way of doing the same question. All right, part B, it says Scott invests $500 for 7 years at a rate of 1.5% per year, simple interest. Calculate the value of an investment at the end of 7 years. Okay, so you have I equals PRT over 100. All right, that's the formula for simple interest, where P is the amount invested, which is 500, and R is the rate, which is 1.5. Okay, and T is the time for which you invest it, which is 7 years. All right, so this is going to give us P, which is 500, times R, which is 1.5, times 7 over 100. So those will cancel. You're left with 35 times 1.5. You have 5 times 1.5 times 7, and that gives you 52.5. Now that is the extra in his account. Okay, the simple interest formula gives you just the extra amount in his account. That's just the interest part. So the value of his investment is now the original amount plus 52.50, which is $552.50. So be careful that the simple interest formula tells us just the extra in the account, doesn't tell us the value of the new investment. Okay, whereas with the compound interest, if it was compound interest, then finding the answer using the other formula for compound interest will tell you actually the value of the whole new investment, not just the extra part. Okay, part C. It says in a city the population is increasing exponentially at a rate of 1.6% per year. Find the overall percentage increase at the end of 20 years. So this is like a compound percentage problem. So it's increasing, okay, by 1.6% every year. That means every year you got the original population plus 1.6%. So it's 100% plus 1.6%, which is 101.6%, which you can write as a decimal as 1.016. That's that as a decimal. So that's like the amount you have to multiply the original population by every year for 20 times. So let's say the original population was 1. Okay, it doesn't matter what you use as the original population. First, we're finding a percentage increase. So it's going to be the difference between over the original times 100%, percentage increase. So let's say the original population was 1. Then we can say that you have basically 1 times 1.016 to the power of 20. That will tell you the population after 20 years. Okay, after 20 years. If you take away from that the original population, which is 1, and divide that by the original population, which is 1, and you multiply that by 100%, that will give you the percentage increase. Now, it really doesn't matter what number we put in this place. If I say there's 100 people we started with, it'll be this, and there'll be 100 here, there'll be 100 here. They'll cancel out to give you ones anyway. All right, so it really doesn't matter what number you use here. I'm just using 1, okay, because it's easy. So all I have to do is just this, basically, times 100. Okay, and that will give me my percentage increase. So that's going to be basically, it's just going to be, I don't even have to put 1 times, I can put 1.016. That's increasing something by 1.6%. How many times? 20 times to the power of 20. That's the new population after 20 years. Take away 1. Okay, that will give us the difference between the original population and the population after 20 years. And I want to convert that into a percentage. So I divide it by 1, which will be the same thing because the one we said 1 is original. And you multiply it by 100%. So you multiply by 100 and your answer will be as a percentage. So that gives you 37.364. 37.364%, which is, we can write here as 37.423 SF. Okay, I could have used any number. For example, if I had used 100, just imagine we say let the original population be 100, okay, and we then do this, it will give us the same answer, okay, because basically these hundreds will cancel out, you see. So let's just do that this way, and you can see, if I did it in this way, we have 100 multiplied by 1.016, to the power of 20. Okay, and then take away 100. So that's the new population. That's the population increased by 1.6% for 20 years, minus the original population, which we said was 100, divided by the original population, which is 100. And you take this fraction and you multiply by 100, and the answer will be in percent. You see, you get exactly the same answer. All right, so whatever number I put here, okay, I could use 10, I could have used 100, I could use 50, any number, you'll get the same percentage increase. All right, so there's the answer to part C. Now, part D says the population of a village is 6,400. The population is decreasing exponentially at a rate of R% per year. After 22 years, the population will be 2,607. Find the value of R. Okay, so now here I'm going to use the actual formula for compound interest, compound percentages, which I could have used here as well, but it's basically what I'm gonna do here is basically the same thing that I did there, but using the formula here might just be a bit more useful. So the value of the population is going to be, now in this case we're going to have the original population. Okay, so this is the new value v. The old value is p. You multiply that by, now if it's decreasing exponentially, first of all we know that it's going to be a compound percentage exponentially, and if it's decreasing you do 1 instead of 1 plus like we did here. Basically what we did here was 100% plus 1.6%, which is like 1 plus 1.6. Okay, 1 plus, not 1.6, we did 1 plus 1.6 over 100 basically. Yeah, just changing that into decimals. All right, that's what gave us 1.016, sorry. So here what we're going to do is we're going to take away r over 100, okay, and raise that to the power of 22, okay, because it says after 22, all right. That's what the value of the population is going to be, and we know that v is equal to 2,607. So we can say here that that's going to equal 2,607. All right, so that's what we can set up. So we know the original population, so we can say that's equal to the new value. I'll just write it in terms of these right now. So that's the new value. The new value of the population is the original population times 1 minus the rate over 100 to the power of the number of years. That formula is what we need for this exponential increase, and in this case decrease. It's minus. If it was increasing, I'll put plus here. So the original population, okay, is 6,400. You have 1 minus, we got to find the value of r, so that's r over 100 to the power of the number of years, which is 22, and that's equal to the new population, which is 2,607. So to solve this, what I'm going to do, I'll have 1 minus r over 100, all of that to the power of 22, is equal to 2,607 over 6,400. And the next step is I will take the 22nd root of both sides of the equation. So I have 1 minus r over 100 equals, now I'll put the root, the 22nd root of 2,607 over 6,400. Okay, and then what I'll do is I'll just make a little line here so I can continue. What I'm going to do is I'm going to rearrange this so I have 1 minus the square root, or not square root, the 22nd root of 2,607 over 6,400. Okay, and that's equal to r over 100. So therefore our r is going to be 100 times all of this, 1 minus the 22nd root of 2,607 over 6,400. And that will give us what our r is. So let's see if that works. So we have 100. Then we have brackets 1 minus the, now I'm going to use this button here. This one here. So shift and this button. And I can choose the root I want. I want the 22nd root of, and I'll have the fraction here, 2,607 divided by 6,400. Then I'll close that bracket. Oops, no, close it out there. Okay, so that's 100 times 1. Yeah, so that should give us our answer without having to have done any rounding before. That's why I didn't calculate this and write it as a decimal. I just rearranged to make r the subject. So I first subtracted this from both sides and added this to both sides. So I have 1 minus that root thing equals r over 100, then multiply both sides by 100. And that should give us the right answer, which is 4. Basically, it's 4.00006, 4.00006, whatever. So you can write that as 4% if you want. R is 4. You could write it as 4.00 if you want to. Okay, both of those would be acceptable. Okay, because it's not really an exact answer quite, but you can take it as an exact answer because it's, all these decimal places are zeros before you reach the next number. So you can write it as 4. You can write it as 4.00. Both of those would be acceptable in this case. And that's the answer to part D of this question. And I think, yeah, that's this question here completed. Question 8. All right. So other questions from this paper. once I'm getting around to do it. I mean, these older papers I will answer by request rather than doing the whole thing. So if you have a request from this particular paper, this is the paper 4 variant 1 from the May-June 2019 Cambridge 0580 syllabus, then you can send a request and I will answer another question. And the playlist for where I'll collect them together is located somewhere over here. And there's also a playlist for the topic of percentages, which you'll find in this area over here. Or click on that. It'll take you to all the questions I've answered on percentages from this IGCSE topic, and you can subscribe to the channel by clicking on this link. Thank you for watching. See you soon.